What's the difference between a data scientist and a data analyst? This is really poorly understood. So I want to explain the differences and then talk about how you make the transition from a data analyst to a data scientist now that you have a better understanding of what the difference between the two is. A lot of companies confuse data analyst, data scientist. They'll ask a data scientist to do primarily data analyst's work. And so that's where a lot of the confusion comes from. It stems from the fact that companies rarely understand the differentiation. And I break it down this way. If you look at a data analyst looks at data, analyzes data, and pulls out insights about behaviors. And typically these are behaviors about systems, business systems, or anything to do with the way a business operates. Insights about customers and the way customer systems operate or marketplace systems operate. And so they'll look at a large data set and they will pull insights about the way that these systems behave. A data scientist will use experiments to understand the dynamics of a system, to understand those systems that the analysts are looking at from a behavioral standpoint. The data scientist is not just going through data, but doing experiments to understand the dynamics, which is a deeper understanding, a correlation, and hopefully moving towards causal understanding of why the system, whether that's a customer, whether that's competitors, whether that's something internally, operationally about the business. It is an understanding of how that system functions and why it functions in the way it does, the governing dynamics of it. So let me dive into a little bit more of a description of a data analyst. And so your data analyst, you can actually think about it as, 4 or 5 years ago, a data scientist compared to what a data analyst now is, it's the same thing. So the data scientist, the descriptive modeling and the analytics, those roles have now been offloaded to data analysts. And I think that's a good fit for it because everything from your even advanced analytics using machine learning techniques, and you'll hear this asked for when you talk about an analyst role. And if you're an analyst, this is probably something you do a lot. You actually use data science methodologies. You use things like regression, clustering, decision trees, and so on. Those basic core methodologies of data science are used in your day-to-day analysis. You are probably technically proficient. You have some of the same technical proficiencies that a data scientist does. You're probably really good with databases. You may even be better with databases and data sources and SQL than some data scientists are. You have Python programming skills, more likely than not. You have that customer interfacing or internal user interfacing, some understanding of the business acumen, business strategy. And this is the data scientist 5 years ago. And so that's what I say when I say the overlap is significant between what a data scientist used to do and what an analyst does now. You're probably a little less when it comes to software engineering capabilities than a data scientist is or an ML engineer might be. You're very focused on the visual aspect in more cases than not. It's presentation, it's the ability to communicate data and insights to stakeholders, to people that are sometimes non-technical, maybe even not really that data literate. And so you have a stronger focus on the business capabilities, and so that leads to better focus on visualization, presentation. And so that's an analyst. And I know you can listen to that and go, there's a lot of overlap with what we thought data science was about 5 years ago, in which some companies, I'll admit, some companies are still stuck in that older paradigm, thinking of data scientists more as descriptive modelers. But they're not anymore. If you look at the majority of job descriptions that are out there and what data scientists actually do in their day-to-day role, it's evolved. And that's why I say instead of just talking about data, I talk about using experiments to understand systems. And that's really the key differentiator is an analyst will use data to understand behaviors. A data scientist will use experiments to understand systems. So what does that mean? You're often going to get asked as a data scientist to use state-of-the-art model architectures. Some people quote it in that deep learning bucket, and it's not necessarily all deep learning. There's a whole lot of model architectures that are modern, state-of-the-art, and not I guess in the traditional bucket of what you would think of as deep learning, but you need to be more on the cutting edge. And that means you have to have a more complex understanding of things like custom model development and architecture. Probably have a deeper understanding of the math, the foundational concepts that explain what models are, why they work. And again, back to how you would customize a model for a particular business case or use case. You're going to see more of a focus for a data scientist on engineering for production, not so much for visualization, but for actual production, something that's going to function in a large scale environment or in a complex environment that may be internal, external, customer facing. So there's more of a software engineering focus in those patterns, architecture practices. Now, I sort of covered this, but also it's the scale of the amount of data that you're going to be consuming, the complexity of the pipelines that you're going to be working with, the complexity of the data sets that you're going to be working with, talking about streaming and batch, but not just in a way that's going to lead to a dashboard product, but doing that ETL that leads to a high quality, sometimes unique data set that can be consumed by a model, and you can build reliable models on top of. There's also the research focus. When I talked about experiments, it's not just about the data. You don't typically have enough data to truly understand the systems. You can understand their behaviors, and again, that's what the analyst does. But as a data scientist, you're trying to understand something more complex, which is the system that leads to those behaviors. And again, I covered a couple of different scenarios, but looking at everything from customer behaviors to competitors' business systems to building a service, a model that serves inference to support a product. When you talk about autonomous vehicles, great example. What is the system that they're trying to learn? Well, it's very complex in that case. The system that they're trying to learn is every system you could interact with as this car is driving to allow it to operate safely. And those are a lot of different systems, and those are more production-facing systems, more complex. And it's not enough to simply understand the behaviors. You have to have that correlation moving towards causal understanding and building out causal graphs. So your car doesn't slam into something because a stop sign had a couple of pixels out of place, which if you don't build robust, reliable models, that can happen in the real world. And obviously you don't want that to happen to your autonomous vehicle. And finally, there's more of a focus on a complex workflow. And this is, I won't get too deeply into this, but the data science workflow is broader, and it goes all the way from, like I said, that complex pipelines. You got your research, and then you have your model development, implementation, and support in production. And so that workflow is significantly wider than a data analyst's workflow. So that's really that's the end difference. And if I wanted to really sum it up, I'm going to give a summary for a data scientist. They're more focused on interventions, understanding the impacts of interventions. I do something, for instance, serve an ad to a customer. What happens? Is that the optimal ad? Was that the optimal timing? So we're more concerned as data scientists with interventions than we are with just pure insights. The interventions themselves and understanding how interventions impact a particular system gives us the data that allows us to understand the system itself, and gives us, as a result of that experiment, a better understanding of those system behaviors, of the emergent behaviors of the system, so we can prescribe policy, whereas an analyst is focused purely on insights, looking at the data that they already have gathered from behaviors. So how do you make that transition? Now that you really understand what the difference between the two are, how do you make the transition? First thing to learn and focus on is software engineering patterns and practices. Improve your software development skills, improve your skills with your core architecture, building reliable software for production, those complex environments that I was talking to you about earlier. Learn more of the math foundations for all of these more complex deep learning and more leading edge model architectures. So you want to spend some time understanding what those all are. I mean, everything from generative adversarial networks, you should probably spend a lot of time because there's a lot of focus being put on that. Understanding things like synthetic data, transfer learning. And there's this huge, I could go on for 20 minutes about just what are the modern machine learning architectures, but those are the ones that you want to begin to understand. are these more complex model architectures. And then, like I said, that foundational mathematics, it's key because you're going to have to customize these models. You can't just do the import from, there's no auto ML for custom model development. There are some really cool use cases for common sort of business applications, but as soon as you start getting into the more complex, more niche applications that you as a data scientist are going to have to implement and have to meet the business needs for, then you need that deeper understanding of math, because that's the architecture that helps you understand the models in a way that you can actually build for specific use cases, specific business needs. Once you have those pieces, you have the software development, you've got the math, you want to go towards science. So the science piece of it is obviously your statistical methodologies, your statistical experimental methodologies, but also your hardcore science methodologies. How do you build an experiment? There are simplistic experiments in machine learning, and then there are all the way on the other side, the simplistic experiments are ones that are more model focused, where we have this massive data set and we want to study, like I said, the impact of an intervention on a particular system to start looking for causal relationships between the two. But the more complex experiments from a science standpoint are ones where you actually execute a science experiment, and you need to understand how to design experiments outside of just really playing models off of each other, doing a rigorous architecture on a couple of different models, and then attempting to use those differences in architecture to prove some sort of relationship between your intervention and your system and your outcome. And so there are rigorous science experiments, and there are these more statistical model focused experiments, and you need to get a background in both of those. Now, the more complex workflow, it sounds like there's more to learn there, but I'll be honest. As an analyst, you have a lot of the workflow already done and well understood. You understand data. You understand pipelines. You probably need some technical skills to build more complex pipelines. So, like I said, you're going to be getting a bit more of the software engineering patterns and practices. You should also get good with more complex platforms that do the ML ops as well as the data engineering side. So those are good to get to know, because they'll introduce you to what tools you'll be using as part of, like I said, that more complex workflow. But to be honest, there's not a whole lot of gap to fill in once you've gotten through your additional foundational math, getting more into the software engineering side and becoming a better software developer, software architect, and then finally understanding the research side of data science. Not just the statistics, but the experimental design methodologies that go with a more rigorous science experiment that it builds a whole lot of business value, because you're creating unique artifacts that the company can use as a competitive advantage. And that's one of the reasons why a lot of companies are going towards this applied research approach. And so I think I pretty much covered it. Whatever you do as an analyst, don't lose your communication skills. Don't lose your business acumen. Don't lose those things that allowed you to be successful as an analyst, because they're going to be differentiators for you as a data scientist. You're going to be a better data scientist because you are a strong communicator. You can work collaboratively with technical and non-technical audiences, with multiple business units. Like I said, you're an effective communicator, and that's awesome. And you have that business acumen. That's something that's increasingly in demand in the data science field. And so don't lose all of those benefits of having been an analyst. Just add on to them. And remember, I'm talking about science. I'm talking about hardcore math. You're not going to become a scientist. Don't worry about that. It's going to take you years. And most people are still figuring out experimental design and methodology in data science and machine learning. So it's an evolving component of the field, and we're just getting into causal modeling. Although it's been around forever, trying to get it to work in a machine learning framework has been challenging. We've made a lot of progress, but it's a work in progress. So you don't have to become a PhD in math or a hardcore scientist. You need to understand the foundational concepts that explain model architecture and allow you to customize them. And you have to understand experimental design, and that's it. Don't worry about, like I said, don't worry about going, way too far downfield with this. Get proficient with those core areas, and you'll be ready for your first data science role.